Penny is approximating the area under the curve for the function 2 to the power of x. She writes the sum of the rectangles as this here, and Scott is playing with his calculator, and instead of working on his assignment, brags, "Since I know the endpoints of the intervals are integers, I can tell you everything you want to know about the area just by looking at your sum." So we're going to go ahead and talk about what we know just by looking at this sum that is written by Penny. So from here, determine the number and width of the subintervals. So in this case here, the width here is going to be 0.4, because if you see here, the only thing that is increasing each time is going up by 0.4, which also, again, should match here for what our original width is for the sum of our rectangles. So I'm going to call the width 0.4. The number of them takes a little bit more work. I'm going to deal with that in just a second here. But to determine the domain of the interval, when I'm looking at the interval itself, it's going from 1 to 2.6, right? So really what I should see here is that, let's say that we start at k equals 0. When I plug in 0, I'm going to get 1. When I plug in 1, I'm going to get 1.4. I'm going to plug in a bunch of numbers and get to 2.6. So to find the equation here that would give us this, I know that it's going up by 0.4 each time, so I'm going to say 0.4k. And since my starting interval is at 1, I got 0.4k plus 1. So what that means is that if I'm going to set that equal to, if I set that equal to 0.4k plus 1 equals 2.6, I can find the k value that we end at. So I'm going to subtract 1 from both sides. 0.4 equals 1.6. I'm going to divide that, and I'm going to get k equals 4. So basically, I'm starting at 1, 2, 3, and 4 gives me 2.6. So what that means is that there's 1, 2, 3, 4, actually 5 numbers here that I'm dealing with. So I'm going from 0 to 4. And then my interval, again, is 1 to 2.6, because those are all my x values. So now I should have enough information to give me sigma notation, because I'm starting at 0 and ending at 4. So 0 and 4. My equation here is 0.4k plus 1. And then again, we have, my fault. My equation is not that. Remember, that equation gave me the exponents up here. So really my equation is 0.4 in parentheses, then 2 to the power of 0.4k plus 1. And so that is my sigma notation to give me the area of all of them. The last question here says, were Scott and Penny using left or right endpoint rectangles? And technically, the way that I worked this out, this would be left endpoint, but truthfully, we weren't necessarily told where we were starting. So technically what we could do is we could say that this k value here was 1 that we started at, and we went to 5. And basically the only difference here would just be, that we would have to change the equation a little bit. But if I'm using this equation here, it would be left endpoint. It would change the equation a little bit, because it would be, 0.4k plus 0.6. If we were using this as part of our sigma notation equation, then we would say it's right endpoint. But either way, we're not sure because they didn't tell us where they were starting.